purpose of this short video will be to just remind ourselves of the absolute basics of atomic structure that we should all know. We're guaranteed to get a few marks of questions on this. So if you're looking at an atom, you should be aware that an atom is made of a nucleus, which is positively charged and are very tiny, and it's surrounded by shells which have electrons in them. Okay, so it might look something like that. The nucleus is tiny and it's made up of protons and neutrons, and we need to know that the nucleus is many times smaller. We should have an idea that it's about 10,000 times smaller than the size of the atom, and atoms themselves are extremely tiny. We should know these basic facts about those components, the subatomic particles of atoms. We should know that a positive charge, so it should be a +1 charge for protons. Neutrons have 0 charge, that leaves you with electrons must have 0 charge, and atoms always have the same number of protons and electrons if they're neutral atoms. So we'll talk about ions in another video. So there must be the same number of those, so it's overall neutral, same number of pluses and minuses. The mass of protons, electrons and neutrons is extremely tiny for all of them, but we need to know their relative masses, and essentially the relative mass 1 is equal to the mass of a proton and the mass of a neutron. So the particles in atoms that give atoms some mass are the protons and neutrons. Electrons have almost no mass, so we can say negligible is a perfectly reasonable way of saying they have almost no mass at all. Could be 1/2000, something like that as an idea. The location of protons and neutrons, as I've already said, is in the nucleus. Oops. Nucleus, nucleus, and the electrons are in shells. Okay. Right, we need to know that we can work out the structure of a particular individual atom by looking at the elemental symbols. Now, little tip for you, please remember to make sure all element symbols have a capital letter to start with. And then if there is a second letter, which there isn't always, it's always lowercase. And people lose easy marks sometimes because they might write argon like that, for example, or write chlorine like that. That's not okay. Right, so here's two examples, argon and lithium. The smaller number, usually written at the bottom, is what we call the atomic number. So atomic number is equal to the number of protons, and that's a definition you should know. Atomic number equals number of protons, and that defines what the element is. If the element has got 18 protons, it must be argon. It's always argon and nothing else. And if the element's got 3 protons, it must be lithium and nothing else. Now, in a neutral atom, the number of protons will equal the number of electrons. But electrons can come and go when they form ions, as we discussed another time. So definition is what I've written here. Atomic number is equal to number of protons. The bigger number, I put a box around here, is what we call the mass number. And this comes up quite a lot in past papers. Definition of atomic number, definition of mass number. The mass number is simply defined as number of protons plus neutrons. And so if you've got a mass number of, say, 40, like we do up here, we can work out the number of neutrons by doing 40 take away 18. So the number of neutrons is equal to the mass number take away the atomic number. Don't get confused about relative atomic mass. We'll talk about that. Well, I have talked about that in other videos in the past. Look in the quantitative chemistry section if you want to look at how relative atomic mass is calculated, the average mass of all the isotopes. That's a separate issue. So I want to just briefly finish off with electronic configuration. Electrons, or the arrangement of electrons in atoms, depends on how many there are. And so if you've got 3 electrons like we have with lithium that I drew before. So lithium had 3 protons, 4 neutrons and 3 electrons. You can work out where they are because electrons always fill from the first shell, and the maximum you can get in the first shell is 2. The maximum you can get in the second shell is 8. The maximum you can get in the third shell is 8. And you don't need to worry too much about anything in the fourth shell. Okay, the maximum you're going to see at GCSE is up to 2 electrons in the fourth shell. So if it's got 3 electrons, the electronic configuration is 2 in the first shell and 1 in the second shell. So these would add up to 3. If you had argon that I drew before, there would be, we've got to add these up to 18. 2 in the first shell, 8 in the second shell, that's 10. And then 8 more to make 18. So that's 2, 8, 8. If you're asked the electronic configuration, it simply means draw it like this in a line with commas between them. If you're asked to draw an atom of, say, lithium with 2 electrons in the first shell and 1 in the second shell, that's how you would draw it. And in another video, I'll link the electronic configuration to the position of the atoms in the periodic table. That's it, folks. Thanks.